Take a look at the night sky. The pattern of stars that drifts overhead appears fixed. But look for longer, weeks or months, and you'll see a handful of the points move. These slow-moving points of light are the planets, the giant chunks of rock or gas that orbit our home star, the Sun. We thought there were 8. We were wrong.
You know, we think we understand something as simple as our solar system. We've found all the planets. And right in front of us, we miss something big.
A group of astronomers are studying the Kuiper belt, a vast band of icy asteroids that sits way outside the orbit of Neptune. Most of these objects move in a neat, circular formation around the Sun. But the astronomers are puzzled by a small group that appear to break the rules, swinging far outside the main belt on wild, extended orbits. Something sitting far outside the Kuiper belt seems to be pulling these asteroids out of line. Something the size of a giant planet. Caltech astronomer Mike Brown hears about the wild observations and is determined to prove the planet theory wrong.
When we saw these alignments of all these objects out there, we thought, oh, everybody's going to say there's a planet. We have to very strongly prove there's not a planet because, of course, we all know there's not another planet out there. That's ridiculous.
Mike asked his colleague, Konstantin Batygin, to run a computer simulation to see what effect a 9th planet should have on the Kuiper belt. Stunningly, the simulation predicts elongated orbits identical to ones already observed. But the simulation also spits out a surprise. There should be a second set of rogue orbits that are perpendicular to the first set. If Mike can locate these weird, predicted objects inside the Kuiper belt, Planet 9 is almost certainly real.
I took these simulation results to Mike's office, just a couple doors down from my office, and I said, look, we've got a huge problem. He said, no, there's an object called 2012 DR30, which has an orbit just like the one you're predicting.
Mike's asteroid fits the prediction perfectly. He searches the records for more and finds another 4 that seem to be in the right area. But just how closely will they fit the prediction?
I remember sitting back and thinking, okay, we're going to right now plot the data, the real observational data, on top of the model. And Mike said, if these two match up, my jaw is just going to drop to the floor.
The theory says they should be right here and right here. And I did the calculations very quickly to see where they were and brought them up, and there they are, 1, 2, 3, 4, 5, right on these lines, exactly where we predicted they should be. The moment we saw this, we went from cautious to, holy cow, this really is there. We have to make sure to tell everybody right away because it's actually real.
Mike and Konstantin had unlocked the solar system's greatest secret. Planet 9 was almost certainly real, and it had to be huge, perhaps 10 times the mass of Earth.
We're not talking about something like our moon or Pluto. We're talking about something that is literally planet-sized. And we're seeing its gravitational wake affecting these other objects.
The idea that there could be a giant planet that we'd never seen is something I think most of people wouldn't have bet on. But the evidence is remarkable.
To prove Planet 9 exists, astronomers need to see it with their telescopes. But there's a problem. Computer simulations only give a broad idea of where to find it, and Planet 9 is incredibly faint and almost inconceivably far away.
It's much, much farther out than we ever expected to find planets. It probably spends most of its life, if it's on an elliptical orbit, so far away from the sun that we just missed it.
So just how far away is Planet 9? The only way to truly appreciate its vast orbit is to build a scale model. Perhaps the biggest working scale model of the solar system ever attempted. Planetary scientist Kevin Walsh is here to call the shots. And he starts with the size of the sun.
So what we've got here, our kickball, is going to set the scale of our mini solar system today. So everything is scaled off of its relative size compared to the size of the sun.
Kevin quickly paces out the position of the inner rocky planets. All 4 sit within 60 yards of the sun on this scale, and each planet would appear no bigger than a peppercorn. To make this a working solar system, we need to bring on the drones. Each drone represents a different planet, and the orbital speeds have been scaled so 1 Earth year takes just 30 seconds. Already it's clear to see how tightly bunched these inner planets are, and how the closest planets orbit faster than those farther out. Far beyond the tightly packed rocky planets lies the first of the gas giant planets. On this scale, just over a football field from the sun.
So after this 400-foot walk, we made it to Jupiter, the largest planet in the solar system. But even by this size scale, Jupiter is only about the size of a lollipop.
Another football field length lies ahead on the walk to Saturn.
As we look back across the lake bed, I can barely see the drones. We covered a huge distance.
The trek out to Uranus is bigger still. 3 football fields, or the length of an aircraft carrier.
It turns out there's a lot of wind in the outer solar system, so I have to yell. Surprising amount of wind in the outer solar system. Tumbleweed, rattlesnakes.
After Uranus, it's around 200 yards out to Neptune. Before the discovery of Planet 9, we thought Neptune was the farthest planet from the Sun, around half a mile on the scale of our model. But Neptune's distant orbit is nothing compared to the orbit of Planet 9.
So here we are. We made it to the orbit of Neptune. We're only at the tip of the iceberg. We need to stop measuring in feet, and we need to start thinking in miles. We need a car to get out to Planet 9.
Planet 9 swings out on a highly elliptical orbit. Its closest pass to the Sun is a whopping 19 billion miles. That's 6 times wider than the orbit of Neptune. But at its farthest point, Planet 9 is 112 billion miles away. And on this scale, that's an incredible 18 miles from our kickball-sized sun.
So we're here, end of the road. We've driven about 18 miles from where we first started setting up the solar system. But in the scale of the solar system, it's over 100 billion miles. 100 billion miles to get out to the furthest part of Planet 9's orbit. So to scale, and we don't know what Planet 9 would look like, but it's probably about the size of a BB. So this is the challenge for our astronomers. How do you see a BB from 18 miles away? This is what we have to do.
It could take years for our telescopes to pick out an object so impossibly faint and far away as Planet 9. Until then, scientists can only speculate on what this mysterious world might be like.